In this video, we're going to talk about the last way to prove two triangles are congruent. So we already know about side angle side. We could have three sides congruent to prove triangles congruent. We could have two angles and a side at the end, or two angles and the side in the middle. The question is, what about if I've got two sides and then the angle, adjacent to that second side? So you could think about this as side-side angle, or perhaps angle, side, side. And the question is this going to be a triangle congruency theorem? Well, there's actually two things that can happen here, so let me show you. It could be the case that my triangles are congruent. Right here I've got two congruent triangles, ABC and PQR, and they have two sides that are congruent, and the angle adjacent from that second side is also congruent. But notice that they don't have to be congruent, because I could create another triangle that fits those same qualities. Notice those two tick marks stay the same, so that RQ is the same length as RQ in the first picture, but these triangles aren't congruent anymore. So be careful. The only one that doesn't work is angle side side or side side angle, unless we have a right triangle, which is what we're going to explore today. So for exercise 1, given triangle ABC, where angle C is a right angle, AB equals 5, AC equals 3, find the missing side of BC. Now, if you don't remember, we actually have a theorem to help us solve for any side of a right triangle. That's a squared plus b squared equals c squared. That's the sum of the two legs squared should equal to the hypotenuse squared. So that a and b just represents either AC or CB, and c squared represents the hypotenuse. And remember, the hypotenuse is always across from the right angle there. So I'm going to start plugging in. I'll label a as x squared. I'll make b the 3, and my hypotenuse, the longest side, always goes on the right side of that equal sign there. So I'm going to do a little bit of simplification here. 3 squared is 9, 5 squared is 25, and if I subtract 9 on both sides, I get x squared equals 16. So remember to undo a squared. This is just asking you, what number do I have to square to get 16? I can take a square root on both sides, just to find that my missing side length is going to be 4. So notice for this picture, I had a right angle. I'll call that an angle. I knew one side length, and I knew another side length adjacent to it. This is actually angle side side, but notice for a right triangle, if I have two sides, because of the Pythagorean theorem, I really know all three sides. So this is going to be the last way that we can prove triangles congruent. We're going to call this method hypotenuse leg. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another, then the two right triangles are congruent. So let's talk about how we can apply that here. So let's take a look at one example. In the diagram below, AC intersects DE at B such that AC is perpendicular to DE, B is the midpoint of ED, and AD is congruent to CE. And they're tasking us in proving that triangle ADB is congruent to triangle CBE, right there. So really just those two triangles that we're looking at. Not a lot going on here. So the first thing I'm going to do is I'm going to set up my statement and reason charts, and I'm just going to write down the givens that I see. They tell me that AC is perpendicular to DE. Maybe that'll help me get a right angle. They tell me that B is the midpoint of ED. And they tell me that AD is congruent to CE. So that's a lot of information there, and I'm going to start marking that up in my picture. So the easiest thing to start marking is that AD is congruent to CE. Now you need to ask yourself, why are they telling us about this perpendicular part? Why are they telling us that AC is perpendicular to DE? Well, anytime I'm thinking about perpendicular lines, remember perpendicular lines intersect at right angles. So I can make the assumption that that angle right there, ABD, and angle EBC, are congruent right angles. So that's going to be the first inference I make. I'm going to say that angle ABD is congruent to angle EBC. Notice B is in the middle for both these because B is where the vertex is, but I can't just call these angle B because there's more than one angle at B. So the reason I know that's true is because perpendicular lines form congruent right angles. So that's the first thing I notice. So it's already looking like these are right triangles. And if I'm trying to identify the hypotenuse, remember the hypotenuse is across from the right angle? So in both these triangles, I've proven that I have a hypotenuse congruent and that they have a right angle. So for hypotenuse leg, all I need to show is that another side of each of these triangles is congruent to one another. So I'm going to go back to my givens and see what I missed. Notice that I didn't use B is the midpoint of ED yet. So if B is the midpoint of segment ED right there, that just means that it's cutting it in half. So I can make the inference that EB is congruent to BD. That's going to be my next statement here. EB congruent to BD. And the reason I know that is because it's the definition of a midpoint. So you could say midpoint divides a segment into two congruent parts. I'm going to use a little bit of shorthand here. Midpoint cuts a segment in half. All right, so it looks like I have enough information to prove the triangle ADB is congruent to triangle CBE. Notice I'm just rewriting that proof statement that they gave me, just so I don't mess up the order of the letters. And my reason for that is just hypotenuse leg. So the whole idea is that these are two right triangles, and what we really did was side, side, angle, or angle, side, side here. But because it's a right triangle, it technically works. I've shown that a hypotenuse and a leg in both of these right triangles are congruent to one another, so it's enough to say that these two triangles are congruent. Now, just something else to be thinking about. If you've proven that two triangles are congruent, it should be the case that angle A and angle C should be the same, angle D and angle E should be the same, and AB is congruent to BC. So we didn't know this before, but once we figure out that the triangles are in fact congruent, we can make an assumption that the corresponding parts of those triangles are also congruent, just in case I need them for something later on in the problem. So let's try one more proof. For exercise number 3, they've given me a lot of givens here, so I'm just going to read them and jot them down. PQ is congruent to SR, QT is perpendicular to PR, SV perpendicular to PR, and QT congruent to SV. So that's a lot of given information, and there's a lot going on in this picture here. So before I even start marking it up, I'm going to look at what two triangles I'm trying to prove congruent. It's telling me it wants triangle PQT right there, and triangle RSV right there. So those are the two triangles I'm going to try to prove congruent. And now I'm going to see what information they gave me that I can mark up. So they tell me QT congruent to SV. That's one side I'm definitely going to be able to mark. They tell me PQ congruent to SR. So it looks like I've already got two sides. If I'm thinking about hypotenuse leg, if I could prove that those are right angles right there, I'd be done. And lucky for me, they tell me that QT is perpendicular to PR. So I know that that has to be a right angle right in there. And I know that SV is perpendicular to PR as well. So that has to be a right angle right there. So it looks like the only thing that I wrote down in my picture that wasn't in my givens were those congruent right angles. So I'm going to start off with angle QTP is congruent to angle RVS. My reason for that is that perpendicular lines create congruent right angles. And you should start to get familiar with these statements and these reasons as you see them more and more often. It's really about just memorizing the definitions of those vocab words from Unit 1. So let's ask ourselves, is this enough information to prove these triangles are congruent? Well, I know they're both right triangles because they have right angles. I know the hypotenuse is located opposite that right angle. So even though for these triangles, it looks like an angle side-side ordeal, because they're right triangles, I've proven that a hypotenuse and a leg are congruent in both of them. So this is in fact enough information to say the triangle PQT is congruent to triangle RSV simply by hypotenuse leg. So notice for each hypotenuse leg problem, we always want to prove that we have right angles. Otherwise, this would be angle side-side, and we would run into the issue where we could create two different triangles with that criteria. So remember, this only works for a right triangle, which is why we refer to it as hypotenuse leg instead. So really, those are the only ways that you could prove triangles are congruent. You could prove all the sides are congruent. You could prove two sides and an angle included between them is congruent. You could prove two angles and the side included between them. Angle side, or angle or side angle if you rewrite it, and hypotenuse leg. So those are the 5 ways that we're going to work with for the rest of this unit to prove the triangles are congruent.